So, introduction to mobile graphics technologies. Okay, so in this sort of first lecture, it's basically sort of introducing the students to the module. I'll be skipping over some of this, but basically looking at a brief look at mobile graphics, particularly the sort of the where it's come from and where we're at now, and just looking at the different libraries. Yeah, at least a sort of a brief introduction to at least. So, yeah, I've already mentioned the fact that we've got lecture material, practical materials, and so on. So again, this is just going through that. Now, throughout the entire module, the entire sort of course block, all the teaching material, we cover lots of different things: graphics libraries, graphics architectures, bottlenecks and optimizations. Now, this is one of the key things to take away from, doing desktop environment. You can kind of be lazy. Yeah, your machine might get a bit warm and the fans turn on, but you don't have a battery, so you're not going to run out of power. Okay, in that sense, mobile devices are different. Okay, everything you do, and I told you I'd say this several times, everything you do on a mobile device uses power, you use battery. Okay. So things like transformations, how we manipulate objects in our environments, and also looking at very much about writing your own shader code. Now, shader code is where you write code that lives directly on the GPU. Okay, so you're essentially overriding the default functionality of your graphics chip. So we will be, the full course looks at 3.2, but the majority of the code examples are actually in OpenGL ES 2.0 for the simple fact is if you are using embedded devices, and I think about half of our audience here today are electronic engineers, so it's very, very useful to be able to just deploy directly to it. And all the OpenGL ES above 2.0 are backwards compatible. So if you write in 2.0, it will work with 3.2 and so on. Okay, so yeah. So I've already mentioned the fact that actually 3.0 is backwards compatible. So yeah, ultimately most of the examples or the practical lab sessions in particular are based on OpenGL 2.0. Throughout the full course, where it's appropriate, we'll be talking about the differences, how you can use the newer notation in OpenGL ES 3.0 plus and so on. And the PowerVR SDK also has a lot of example code showing you OpenGL ES 3.0, so you can take a look at that anyway. Now, I've already mentioned this in my introduction. Yeah, so again, it's very much about performance and so on. So recommended resources, we'll be looking at this later, but ultimately there are a number of forums. In fact, I will look at those within the first few lectures. There's also a dedicated Imagination Technologies University Program forum, which I do show later on. So, but there's a whole range of things to actually get you to help, including documentation and so on. The blog is really good. Okay, I'll be honest, I look at this quite frequently. So the PowerVR development team put in new things on there quite regular. They also have a number of presentations. The full SDK is on GitHub, so that's the preferred way of. I believe that's the only way of accessing it now. I know it used to be you used to be able to download as an install, but it absolutely makes sense that it's in GitHub. Particularly, you can just then deploy it straight to an embedded device, for instance. It's much easier. Okay, and all the OpenGL ES standards are on the Kronos website. In terms of book material, I don't think you need it, but you know, students like to have something next to them, in which case, well, at the time of writing these materials, the OpenGL ES 3.0 Programmer's Guide is a very good book. So, a very brief look at mobile graphics, just to show you where we've come from. Now, I am not covering everything. This is just to kind of illustrate some things. But back in '97, Nokia 6110, there was no graphics sort of processing as such. Okay, so there was no GPU, as we call it. So everything had to be done on a very simple CPU. So you've got the likes of sort of Snake, very simple things. Okay, moving on sort of 6 years, you've got the Nokia N-Gage. Now I got one of these. I was actually at GDC, Games Developers Conference that year, and they were handing them out. It was great. So I was given one of these, and this I should have brought it with me. I've still got it. It was a phone that you held sideways, so it looked like a massive ear stuck to your side of your head. And I actually remember asking the developer or the designer of it at GDC in San Francisco that year, why did they do that? And he said it was just a gimmick. And in fact, he advised me to drill some holes in the back of it to use it like a normal phone, because actually the speaker was like a normal phone and it sounded better. But it was just a gimmick thing. But it was really nice because you actually had Bluetooth. You could actually play against other people with Nokia N-Gages and so on. And although there was no GPU, it was all done on a single CPU. You know, there was, you know, you could get some quite low resolution, but you could get some 3D graphics on there. Okay. Now move forward another 6 years, and I've actually moved up to the iPhone 3GS. And things like iPads and so on. Now, this did have GPU, and in fact, it was a Imagination Technologies PowerVR chip in there. Now, this is OpenGL ES 2.0. Okay, so if you have a legacy device like this, you can still deploy to that using the teaching materials that we've got. Okay. Now this is fragment and vertex shaders. We will be looking at that in detail. But essentially, fragment shaders allows us to decide what color every pixel in the screen is going to be. Okay. The vertex shaders allows us to manipulate objects in the environment. Okay. But what's important there, every time that you see the word shader, that means you can write your own code to run directly on that part of the GPU. So you're overriding the default functionality of the GPU. Okay. Yeah. Move forward just a little bit. iPhone 5S, and here again, this was the PowerVR Rogue GPU with OpenGL ES 3.0 capabilities. And just as a little demo, let's see one of the games that was actually developed for that.
I'm remembering who I am, who I was. What do you care about this world? I can't escape my sins. I have to pay for what I've done, he said.
Okay. So when you're looking at a game like that on a mobile device, if you're not very careful, the battery is just going to die. You'll just see it just going down very, very quickly. Okay. So it is really important, if you're going to want to aim to produce a mobile game of quality like that, then there's an awful lot you need to understand from an architecture point of view, as well as within the code and so on. Then just moving on a year or so, we're looking at essentially high-end sort of desktop GPUs previously, and now the technologies available on high-end mobile GPU architectures. So OpenGL ES 3.1 actually adds the ability to use the GPU as another CPU. So the GPU basically is a very good dedicated matrix and vector calculator. Yeah, it does some other things, okay? But ultimately, it's very good at doing matrix and vector calculations. Turns out, pretty much everything in graphics is matrix and vectors calculations, okay? So actually, if you want to use a dedicated processor, and the GPU is just, it is a processing unit, just designed for graphics, or designed more accurately for matrix and vector calculations. So if you want to be able to use that, you can use compute shaders to actually do non-graphics work. And so, still for graphics work, but you can use it as a specialist GPU, which is really, really nice. And with each iteration, we're getting more and more things, including on more modern GPUs, even tessellation. We'll be looking at all of those things. And in fact, this is actually a screenshot from, again, 2014, the PowerVR ray tracing, which was actually a part of their design for quite some time now. And in fact, this demo actually, this isn't ray tracing, this is physically based rendering, which kind of gives you the illusion of ray tracing. And particularly, this is all done in real time, running on the PowerVR Rogue GPU. Now, there's no audio with this, but I said this is a demo that Imagination put together. You can see some very nice sort of atmospheric effects. You've got the light coming through, some nice lens flares. Cool. Okay. Again, just a very, very brief sort of history of sort of graphics libraries, if you like. I remember using SVG back in 2001. So this is a vector-based graphics. So it's a 2D sort of graphics system, but instead of using an image, okay, things were rendered as you wanted them. So just to show you what that basically means is what we actually use now, okay, because vector graphics isn't really a thing anymore, is if you've got a texture, an image, if you blow that up, okay, to maybe sort of it's 4 times it. Twice twice by the X, twice by the Y, what you will find is you get this sort of aliasing. Okay, it doesn't look right because, you know, we've basically just scaled up the pixels and so on. Now, with vector graphics, each of these things are drawn as we need them. Okay, so we don't store an image and blow it up. These are actually generated on the fly for us. So one of the nice things about using vector graphics was it always looked correct for you. Okay. Now OpenGL ES 1 started a year later. Now this, it's a mobile, it's a 3D graphics system, cross-platform as all OpenGL are, which is really, really useful. And we will be looking at, you know, some of the benefits of that, and a whole range of people that were part of creating OpenGL ES. Now, say it was the first of open standard, and it had fixed function pipeline. What that means is you got what you were given. So fixed function meant that you couldn't you couldn't use shader code. You couldn't basically override the default functionality of the GPU. It was highly customizable. You could tweak things and so on, but you couldn't override what you had got. I mean, I remember buying a particular GPU card for my home system because I wanted a special effect to actually happen. Okay, now because we have shader code now, you can create your own special effect on your current hardware. Okay, but at the time in OpenGL ES 1, it wasn't. It was a fixed function. Very lightweight library though. So I said that the ES is the embedded system version of OpenGL, so it's a subset of OpenGL. So there were vertex arrays. Now, what that means is every time you want to render something, you have to send all that information across each frame, which isn't great. Okay. Yes, well, 1.1 came along, and we had things like vertex buffer objects. Now they're great because that means we can store our meshes directly on the GPU. Okay, instead of having to send it all the time and so on, as well as quite a few things like MIP mapping. Now MIP mapping just means if you've got a texture, okay, a large image that you want to apply to your meshes, then if an object is a long way from you, you don't want to be applying a great big texture because fetching that texture from system memory has a cost. And if the thing's only a few pixels big, why on earth do you need this great big texture? So MIP mapping is just the process of creating multiple versions of your large texture. So you might have basically sort of any number of versions of it. And if an object's a long way away and it's only taken up a few pixels, you just use a really small texture because the user's not going to be able to see the detail anyway. Okay. This is all covered in the full module under the texturing and so on, all these things. And also multi-texturing. So multi-texturing is being able to use more than one image on the same triangle at the same time. Okay. M3G came along, didn't last very long. It was actually a Java-based thing. Some games were developed for it, but not too many. A couple of years later, we've got OpenGL ES 2.0. So this is the paradigm shift. And in fact, we've stayed with this. Even your desktop PC, I've got an RTX machine in my office. More was added to the graphics pipeline, but shaders were introduced here. Okay, so the ability to be able to write your own code to override the default functionality of the GPU is absolutely fantastic. Because of that, you cannot, it's not backwards compatible with anything OpenGL ES 1.0. So if you've got any code using OpenGL ES 1. Whatever, you can't run it with this because they're different. Okay, it's a different architecture, hardware architecture and so on. Okay, so as we will be looking at in detail, I've already mentioned this, so the vertex shader allows us to manipulate all the triangles, the properties of vertices in our environment, and the fragment shader will take the output of the vertex shader, and it basically calculates the color of each of the pixels that the object occupies. Now, 6 years later on, we've got WebGL. Now, this is basically based on OpenGL ES 2.0, and it's a JavaScript API. So this uses shaders. Okay, so this does again the vertex and fragment shaders. But WebGL is all about running directly in a web browser. Okay, so it does utilize your GPU, but it's running in a web browser. So just to show you an example of that, we've got HexGL. Okay, so you can see that's running in a web browser. Okay, now it looks great because it is using the hardware on the machine that it's running. Okay, so if you know OpenGL ES, you can migrate across to WebGL quite easily. Okay, it's JavaScript, but ultimately it's very, very, very similar. Okay. So from 10 years ago, OpenGL ES 3 started. So this is fully compatible with OpenGL ES 2 or anything that came before. Okay, it's not compatible with OpenGL ES 1 because it's a different architecture. Yeah. So it came with some new technologies. First being just better support for 32-bit floating points, so you're getting more accuracies. We've got render targets, geometry. So, I mean, render targets, it means that you can, instead of rendering your scene to the screen, as you would do normally, you can actually render it to an off-screen buffer. What we mean by that is, what you could do is just render it to a sort of invisible screen, if you like. You can take the output of that and use that as a texture. So if you were doing, if you had a game where you had security cameras, you could actually render the scene from one of the security cameras to a render target, use that as a texture and apply it to a monitor. So you can do these things. But it also allowed you to do things like deferred shading. Now, deferred shading allows you to do the calculations for pretty much all shading much later on in the pipeline. It also allows for things like ambient occlusion and lots of things. Anyway, it's beyond the scope of this. Is an introduction to mobile graphics. Okay, so we don't cover deferred shading. That would be in a more advanced thing. And geometry instance, then, this is an optimization. So if you've got a model that you want to render lots of times in your scene, then it's a bit like a stamp sort of thing. Geometry instance says that you get the GPU to basically create lots of clones of your thing. So very good for crowd situations and things like that. Okay, it's just a much more efficient way than explicitly drawing 100 versions of your thing. OpenGL ES 3.1 comes along, and this is where we have these compute shaders. Okay, like I've already mentioned, the GPUs are very good at matrix and vector calculations, and therefore actually using it as a specialist kind of processor was available from OpenGL ES 3.1. Yep. Now Vulkan, this is a low-level 3D graphics SDK. It is cross-platform, okay, and it was developed by the Kronos Group, who also did OpenGL ES. Now, it's very powerful, but it's also vastly more complicated than using OpenGL, okay? So as an introduction to mobile graphics, this module uses OpenGL ES. Once you've mastered that, then you should be able to look across to Vulkan and apply that and extend your knowledge, okay? I do embed references to Vulkan throughout the lecture materials, but this is just using, okay, it's on Unreal Engine 4, but this is Vulkan in action. Okay, so yeah, Vulkan is great. So why don't we use this? As I've already said, it's a lot more complex. But just as a sort of brief comparison between the two, OpenGL ES has a single graphics context, okay, and it has this sort of global state machine. So what we mean by that is the GPU, because it's separate from the CPU, it's got no idea where from your application it's being sent any of the graphics commands, okay? So everything is done sequentially, yeah? So the sort of analogy, and now GPUs are multi-core design, okay? But it's a bit like just developing on a single core processor. You know, it's going to do most, at least, of your code sequentially. You know, it'll do line 1, then line 2, then line 3, and so on. Right? Now, what you can do, and as you'll be doing today, is you'll have different classes, all doing their own OpenGL calls and things like that. The GPU doesn't know where in your application it's coming from. It just has this single stream of OpenGL ES calls coming to it, and it will execute those in, you know, as they come. Okay. Vulkan actually is a lot more sophisticated than that. Okay. You can actually have command buffers, so you can actually kind of preload a load of commands, actually send them across. You can have multiple contexts. There's no global state. So the kind of analogy, okay, because I mean all of them are multi-core designs on GPUs. You can have up to thousands of cores on GPUs. Is the idea that you know it's more of a sort of multi-core design that you would have on more modern architectures, where it's been done in parallel. Okay, so it is, but because of that, it's unbelievably. I wouldn't want anybody to use Vulkan as the first exposure to mobile graphics. Okay, you know, once you've got your head up and the setup of OpenGL ES is just so much easier. You know, then after this module to potentially go on to doing Vulkan, absolutely. Okay. Yeah. So because of that. Now I will be showing a Vulkan, and there is another comparison of Vulkan, and when I'm going through the architecture, the graphics pipeline, we'll be looking at those as well.